Today I'll be teaching you how to name alcohol, aldehyde, and ketone, these three functional groups, by using the IUPAC nomenclature. So IUPAC means International Union Pure and Applied Chemistry in e-learning chemology for the subject General Chemistry 2. So for the first functional group, which is alcohol. So alcohol is an organic compound with a hydroxyl or OH functional group on an aliphatic carbon atom. So this is the illustration for the functional group alcohol. It is represented by the general formula R-OH, where R the substituent is the alkyl group. And some examples of alkyl groups are methyl group, ethyl group, and butyl group. In the methyl group, it contains the 1 carbon and 3 hydrogens. And the ethyl group, it contains 2 carbons and 5 hydrogens. While for the butyl group, it contains 4 carbons, but it contains 2, 4, 6, plus 3, 9. So it contains 4 carbons and 9 hydrogens. So alcohol has many uses in our daily lives, and that includes fuel, solvent, and antiseptic. So these are the pictures for the fuel, the solvent, and antiseptic. So for the IUPAC rules for naming alcohols, the first requirement would be the longest carbon chain of carbons containing the hydroxyl group is taken as the parent compound. And the third is the suffix OL replaces the E ending of the parent alkane. And the third one, the suffix increases according to the number of hydroxyl groups present. Example would be hyphen diol, hyphen triol, etc. The E ending of the parent alkane is retained. So let's start off with the naming of this structure. So 2,3-butane diol. So the hydroxyl groups are located in the second carbon and the third carbon. And since the parent chain are 4 carbons, it is called butane. And diol meaning 2 hydroxyl groups. And for this one, 2-methyl, 2-butene, 1-ol. Since the hydroxyl group is located in the first carbon, then it is named as 1-ol. And for the second carbon, the methyl group is located. And also the double bond is also located in the second carbon. That is why it is called butene, in for double bond. And methyl for CH3. So 2-methyl, 2-butene, 1-ol. And since the parent chain are 4 carbons, then this is called a butene. So there are 3 classifications of alcohols: primary, secondary, and tertiary. So it states here that this is the first degree. Carbon atom with OH group is attached to 1 other carbon atoms. And for the second degree, secondary, carbon atom with the OH group is attached to 2 other carbon atoms. So sec would be included in the IUPAC nomenclature. While for the third, tertiary, third degree, carbon atom with the OH group is attached to 3 other carbon atoms. Third is included in the IUPAC nomenclature. So these are the illustrations for the 3 classification of alcohols: primary, secondary, tertiary. So it is present that the carbon atom is attached to the hydroxyl group. While for the secondary, the carbon atom attached to the OH group is connected to 2 other carbon atoms. While for the tertiary, the carbon atom attached to the hydroxyl group is connected to 3 other carbon atoms. So primary, secondary, and tertiary. So for the second functional group, which are aldehydes. This is an organic compound containing a carbonyl functional group. this is the illustration for the aldehydes. It bonds with at least one hydrogen atom and one substituent. So some of the uses for aldehydes can be used as sweet smelling perfumes and colognes, or formaldehyde, a part of aldehydes, can be used as a preservative and antibacterial properties. So these are sweet smelling perfumes and colognes, and the preservatives for antibacterial properties. So the IUPAC rules for aldehydes: the longest carbon chain of carbons containing the carbonyl group is taken as the parent compound. The suffix -al replaces the E ending of the parent alkane. And when it is attached to a ring, the suffix aldehyde replaces the -in of the ring. And fourth, determine and identify the location of the substituents and include it in the parent chain. So, for more examples, 2-ethyl propanol. So the presence of carbonyl group was present in the first carbon. So propanol, because for propane there are 3 carbons in the parent chain. So the E was replaced with Al because there is a presence of aldehydes. There is 2-ethyl because on the second carbon there is a functional group attached, which is the ethyl group. So 1, 2 carbons and 5 hydrogens, which shows that there is an ethyl group present. So 2-ethyl propanol. And for this one, 2-fluoro 1-cyclopentane carbaldehyde. Since this is a cyclic ring, cyclo is included, and carbaldehyde was also added because there is a carbonyl present and attached to the cyclic ring. And 2-fluoro because we start the counting from this carbon right here, and 1 was said because the aldehyde group was attached in the first carbon, and for the second carbon is 2-fluoro because the fluorine is located in the second carbon. So for more examples, 4-bromobenzaldehyde, since there is a benzene ring present and also a carbonyl group attached to the benzene ring, thus giving the name benzaldehyde. The benzene, the ENE of the benzene is replaced with aldehyde. And 4-bromo because when we start counting from this first carbon right here, so 1, 2, 3, 4, thus giving the name 4-bromobenzaldehyde. We will not start the counting from here because this is an attached group. And the second example would be 3-methyl-butanol. So we would start the counting from here, as this is where the carbonyl group was present. So 1, 2, 3. So 3-methyl because the methyl was discovered on the third carbon. 3-methyl, and butanol for 4 carbons present on the parent chain. So 1, 2, 3, 4. Butane, E was replaced with Al. And for this last example, 3-chloro 4,5-dimethyl-hexanol. So we would start counting from here. 1, 2, 3, 4, 5, 6. Thus giving the name hexane. Al replaced with carbonyl group. And 3-chlorine or chloro because the chlorine was discovered on the third carbon. So 1, 2, 3, 3-chloro connected with 4, 5 for the presence of 2 methyls. So 1, 2, 3, 4. The methyl was discovered on the fourth carbon and on the fifth carbon. Thus giving the name dimethyl because there are 2 methyls present on this structure. So 3-chloro 4,5-dimethyl-hexanol. So for the last functional group, ketones. It is an organic compound containing the carbonyl group. So this is different from the aldehyde functional group because neither substituents bond with the hydrogen atom. But if one substituent is a nitrogen atom, then it is classified as a aldehyde. So some of the uses of ketones can be used as a active nail polish remover, and can be used as a solvent for plastic or petroleum based substances, such as these two pictures right here. So the IUPAC rules for ketones: the longest carbon chain of carbons containing the carbonyl group is taken as the parent compound. The suffix ONE replaces the E ending of the parent alkene. And some ketones are also known by their generic names. So for this one, this is called a propanone. So 1, 2, 3, 3 carbons present, and ONE, the E was replaced by ONE because there is the presence of ketones. And for its common name, it is called a acetone. So here are some examples. 2-hexanone. So there are 6 carbons present in the parent compound, so thus giving the name hexane. And the E of hexane was replaced with ONE because there is the presence of ketones. So 2 because the ketone was located on the second carbon. So 1, 2, thus giving the name 2-hexanone. And for this one, cyclohexanone because this is a cyclic ring, and hexanone because there are 6 carbons present in this compound. So 1, 2, 3, 4, 5, 6. And the E of hexane was replaced with ONE because there is a ketone present on the attached on the cyclic ring. So for more examples, 2-decanone. So for this one, the ketone group is located on the second carbon. So count from this one here. 1, 2, 2-decanone. And deca was present here because there are 10 carbons present on the parent compound. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Thus giving the 2-decanone. And this one here, this is a phenylethanone. And ethanone was present because there are 2 carbons present in the ketone. And phenyl because the benzene ring is with the ketone group. So the ethane is replaced with the E of the ethane is replaced by the ONE, thus giving the name phenylethanone. And for this one, 4-ethyl 3-hexanone. And since there are 1, 2, 3, 4, 5, 6 carbons located on the parent compound, thus giving the name hexane. And E is replaced with ONE because there is a ketone group present. And the ethyl group is present on the 4th carbon as we count 1, 2, 3, 4. So this is the ethyl group. So 4-ethyl. And 3 because the ketone is located on the 3rd carbon. So 1, 2, 3, thus giving the name 3-hexanone. So there are other examples. So what if aldehyde and ketone are in the same molecule? So since aldehyde has higher priority than ketone, then the ketone would be named as oxo instead of ONE. So the Al is still retained in the aldehyde. So 3-ethyl 5-oxohexanol. And hexane is located because 1, 2, 3, 4, 5, 6. So that would mean there are 6 carbons present in the parent chain, and Al because the aldehyde is present in this group. So the E is replaced with Al. And 3-ethyl because it is located on the 3rd carbon. So 1, 2, 3, 3-ethyl. and 5-oxo because the ketone group is located on the 5th carbon. So 1, 2, 3, 4, 5. So 3-ethyl 5-oxo-hexanal. So when we name dialdehydes and diketones, propane dial, since there are 2 aldehydes present, it would be named as dial. And propane, the E is retained in this naming. Propane because there are 3 carbons present, 1, 2, 3, thus giving the name propane dial. For this one, 2,4-pentane dione. So since there are 2 ketones present in the 2nd and 4th carbon, 1, 2, 2nd carbon, 3, 4, 4th carbon. It would be named as dione because there are 2 ketones present, and pentane because there are 5 carbons in the parent compound. So 1, 2, 3, 4, 5. So when we name cyclic ketones and diketones, this one, 3-chloro-cyclopentanone. And for this one, when we count, this would start here, since ketones have higher priorities than chlorine. So 1, 2, 3. So 3-chloro-cyclo since it is a cyclic ring, and pentane since there are 5 carbons present. So 1, 2, 3, 4, 5. And the E is replaced with ONE to symbolize that there is a ketone present. But if these are diketones, then this will be named as pentane dione. So for naming carbonyls and hydroxyl in the same molecule, the hydroxyl, instead of OLE, it would be replaced as hydroxy. And carbonyls have higher priority than hydroxyl. So the AL or ONE is retained on the last part. So 5-hydroxy 4-methylpentanol. And there are 1, 2, 3, 4, 5 carbons present in the parent compound. So this would be named as pentanol. This is a aldehyde group, so pentanol. And 5-hydroxy, since we will start counting from here, 1, 2, 3, 4, 5. So 5-hydroxy. For this one, 4-methyl because the methyl is located on the 4th carbon. So 1, 2, 3, 4. 4-methyl. So 5-hydroxy 4-methylpentanol. For the last part, naming carbonyls and alkenes in the same molecule. Since in the right side, this is nearest to the ketone group, this is where we would start the counting instead of this one. So 3-methyl-4-pentene 2-one. So 1, 2, 3, 4, 5. There are 5 carbons in the parent compound. So pentene. Because of the presence of double bond, there is pentene. And 3-methyl from 1, 2, 3. The methyl is located on the 3rd carbon. And 4-pentene because the double bond is located on the 4th carbon. So 3, 4. So 4-pentene. And 2-one because the ketone is located on the 2nd carbon. So 1, 2. So 2-one. So 3-methyl-4-pentene 2-one. And for this one, 2-methyl-3-butanol. And we will start counting from here. So 1, 2, 3, 4. So this would be called as butene. And aldehydes are present. Al replaces the E of the butene. And 3 because the double bond is located on the 3rd carbon. So 1, 2, 3, 3-butanol. And 2-methyl because the methyl is located on the 2nd carbon. So 1, 2, 2-methyl. So 2-methyl, 3-butanol.